In this video, we're going to be looking at the discriminant. Now, this is something that you guys did in both Algebra 1 and Algebra 2, so we're just bringing something that you already know back to your mind. Hopefully, this is something that you'll recognize once we get started. Okay, if you remember from Algebra 1 and Algebra 2, if you take a quadratic that is written in standard form, ax squared plus bx plus c, just putting those variables in there as the coefficients, and I solve this for x using the completing square process, I get this formula. This is the quadratic formula. The quadratic formula absolutely must be memorized. You've already done this in Algebra 1 and Algebra 2. Also, any of you guys who are going forward to university will take a college placement exam, and you'll be expected to know this. You will not get a formula sheet on the college placement exam. So you need to be prepared to have this formula in your memory bank. Hopefully, most of you guys already memorized this, Algebra 1 or Algebra 2. There's some songs that go with it. If you want to Google songs that go with the quadratic formula to help you memorize it, but this is something that absolutely must be memorized. What we're going to focus on today is this purple part of the quadratic formula right here. This is called the discriminant. Write that on your paper. This is the discriminant, b squared minus 4ac. The discriminant tells us the type of root that we have. It does not tell us exactly what the roots are. Like if I want to solve for x, I have to do this whole thing. And you can see that today we're only focusing on a portion of that. So it's not sufficient to tell us exactly what the roots are going to be. It's just going to tell me what kind of roots that I have. And that sometimes is a valuable piece of information to know. Please notice that the square root itself is not part of the discriminant, only the purple part, not the square root. Another thing is if I ask you on a quiz or a test for the value of the discriminant and you do the whole quadratic formula, what that tells me is you don't know what the discriminant is, and so you're not going to get credit for that. If I ask you for the discriminant, you must only do this part. Okay, so let's investigate the discriminant. What happens if the discriminant is positive? Okay, so you can see I have my quadratic here, and I have it set equal to 0. I'm going to do a equals b equals c equals just like we did when we were factoring. And turns out a, b, and c are exactly the same because it's still a quadratic in standard form. So a is this one in front of the squared term. B is this one in front of the x to the first term. And c is the constant. C is the one with no x. Okay, let's substitute that into the formula. So b squared, I've got negative 4 squared. And it's really important that that negative 4 is in parentheses. If you do not put it in parentheses, when you go to put this in your calculator, you're going to get the wrong answer. So be really careful to put that in parentheses. Negative 4 is part of the formula. A is 3, and C is negative 11. Okay, when I type that into my calculator, I get 148, which is greater than 0, so it's positive. Okay, so now think about where that 148 is in the whole quadratic formula. It's inside this square root. So can I take the square root of a positive number in the reals? Sure, I can take the square root of every positive. So that tells me that the two roots that I have, and I know there's 2 because the exponent is a 2, right? And the highest exponent tells me how many solutions or how many roots I'm going to have. So I have 2 roots. Both of those roots are real, because I can take the square root of any positive number in the reals. And also, if I do a factor tree on 148, it's not going to work out to be a perfect square number. Every number is not going to be in a circle. There's going to be some that are left over to go back inside the square root. So that tells me that my solutions are irrational. Okay, so this tells me the type of the solutions that I have. Notice I don't know what x equals at this point. I just know the kind of answers that I'm going to get for x. There are going to be 2 of them. They are both going to be real, and they're going to be irrational. Okay, let's look at that on a graph. If I graph the quadratic 3x squared minus 4x minus 11, I'm going to get this parabola. And look at where the parabola crosses the x-axis. Remember, the x-intercepts of the graph are the solutions or the roots. Here's one of them. Here's one of them. Okay, those are not exact answers. That decimal is rounded to the third place, tenths, hundredths, thousandths on both of them, right? So in this case, I have two irrational roots because that's not an exact answer. That is a rounded answer. But it did cross the x-axis twice, so my solutions are real. They're just irrational. Okay, well, turns out there's another possibility when b squared minus 4ac is positive, so let's investigate that. Well, this one is different because I don't have equal to 0. You guys remember when we were factoring, before we could say what a, b, and c were, we had to make it equal to 0. The same thing is going to be true here. So I'm going to make this one equal to 0, 3x squared minus 2x minus 5. Those are not like terms, so I'm not going to put them together. Now I can identify a, b, and c. So a, the one that's with the squared term, the coefficient there is 3. B, the coefficient on x is -2. And C, the constant term, is -5. Okay, same thing. I need to be really careful here when I put this in my calculator that I put the -2 in parentheses. If I don't put that 2 in parentheses, my calculator is going to give me the wrong answer, because what it's going to do is it's going to square 2 and then it's going to make it negative, which is not what I want it to do. All right, 4 is part of this formula. A is 3 and C is -5. Okay, so if I type that into my calculator, I end up with 64. 64 is greater than 0, so my number is positive. And you guys probably remember the square root of 64 is 8. That's a perfect square number. If I did a factor tree on it, I would circle 3 sets of 2, and nothing would be left over to go back inside the square root. So it's a perfect square number. So just like before, my highest exponent is 2. So I'm going to have 2 solutions, or 2 roots. My roots are going to be real because I can take the square root of any positive number in the real numbers. But this time, my solutions are going to be rational because it was a perfect square number. If this works out to be a perfect square number, square root of 64 is a perfect square, then I'm going to have rational solutions. All right, let's see what that looks like on a graph. Okay, so I have to graph the quadratic after it's equal to 0. This is the one I'm looking at. And look, it has 2 x-intercepts, so those are my 2 real roots, or 2 real solutions. And look at the x value. I've got an integer right here. Now right here, this one is rounded, but what it's rounded from is 1.6 repeating, and repeating decimals are rational numbers. So integers are rational numbers, repeating decimals are also rational numbers. So both of mine real solutions and also rational, because my square root, the value of my discriminant, turned out to be a perfect square number. Okay, so what happens if b squared minus 4ac is negative? Let's investigate that. So I don't have this equal to 0. I'm going to have to move some things around. So I'll line up my like terms here as I'm subtracting 2x and I'm subtracting 8. Notice I did the opposite of both of those. Several of y'all have asked me about that. So I've got -x squared minus 1x minus 16. You don't have to put that 1. You can just put -x if you want to. All right, so let's do A, B, and C. Okay, identify for me. A is -1. B is also -1. C is -16. Okay, let's substitute that into the discriminant. So I've got b squared minus 4 times A times C. Let me type that in my calculator. I'm going to have -1 in parentheses squared, being really careful with those parentheses. And I'm going to end up with -63. Okay, so the 2 tells me I have 2 solutions. And if I put that negative number inside the square root, you guys know we've already talked about this. When you have a negative inside a square root, what kind of answer do you get? Well, you get imaginary. So this -b right here is going to be real. This square root is going to work out to be imaginary. And when I have a real and an imaginary put together, do you guys remember what we call that kind of number? It's a complex number. So I have 2 solutions, and my solutions are complex, which means it's real plus imaginary. Right? Because b is just a real number, right? It's the coefficient right here. And this part works out to be imaginary because it's the square root of a negative. Okay, let's see what we have on a graph. So here's the quadratic after it's set equal to 0, and I've graphed it. You can see my parabola down here. How many times does it cross the x-axis? Well, none, because this is a real graph, and I had imaginary solutions, so it has 0 x-intercepts. It never crosses the x-axis at all. So that's how I know that both of my solutions should be imaginary, because I'm not crossing the x-axis. I cannot graph imaginary numbers on a real graph. Okay, so we have another possibility. We've already looked at greater than 0. That was our positives. We've looked at less than 0. That was our negatives. Now let's look what happens when it is exactly equal to 0. Okay, so this one's already in the right form. I've got it equal to 0 right there. Let's identify A, B, and C. Okay, so A is 4. That's the coefficient on x squared. B, negative 20. That's the coefficient on x. And C, positive 25. That's my constant term. All right, so I've got b squared minus 4 times a, which also happens to be 4, times c. All right, and I already said this one's going to be negative, but I'm going to type it in my calculator just to make sure. And it is, in fact, equal to 0. I'm sorry, not negative. It's supposed to be equal to 0, and it is. So what happens is I have a 0 right here. Okay, so think for just a second with me. Square root of 0. What multiplies by itself to be 0? Well, 0. So that means when I go to do the quadratic formula, this whole part is going to go away. Because if I add 0 or I subtract 0, I end up with the same thing, right? Negative b plus 0 is negative b. Negative b minus 0 is negative b. So it doesn't change regardless of whether I add or subtract 0. It's still going to just be negative b over 2a. Okay, well that seems weird because negative b over 2a is just equal to one thing. And I have a 2 right there, which tells me I should have two solutions. Okay, so this is a little bit tricky. I do actually have two solutions. It's just that they're identical to each other. So I have one solution twice, and I'll write that down here in parentheses. Because sometimes you'll see that when x equals, or when the discriminant is equal to 0, you'll see that you have one solution. What they actually mean there is that you get that one solution twice. So if the solution turns out to be 7, I'm going to get 7 and 7. So I do have two solutions. It's just that they're the same as each other, so there's no reason to write it down 2 times. 7 is already written down. You don't have to write 7 and 7, right? 7 is already there. So I have one solution, and it's written twice. Turns out to be this, negative b over 2a. Okay, well, that's written as a fraction. So that tells me that my answer is rational, because any number that can be written as a fraction by definition is rational. And also the square root part went to 0. So in this case, there is nothing to be irrational because the square root part went to 0. Also, b is a real number and a is a real number. You can see them up here. There's b and a. And so because of that, my solution is real. Okay, so let's look at what that looks like on a graph. Here's my parabola, 4x squared minus 20x plus 25. And look what's happening right here. It's touching the x-axis and it's bouncing off. So that's a little bit different than what we saw right here, right? This time it went through the x-axis twice because I had two different solutions. But in this case, it's touching the x-axis and then it's just bouncing, like if you were jumping on a trampoline. It just turns around and bounces back up again. So that's what we call a double root. 2.5, which is a rational number, 2.5 is the solution twice. So if I solved this, this would actually work out to be a perfect square trinomial. It would factor to be 2x minus 5 and 2x minus 5. So when I set that equal to 0 to solve it, I only need to do it once, right? Because it's the same thing 2 times. And I'm going to get x equals 5 halves. I'm just going to get x equals 5 halves twice. And 2.5 is the decimal equivalent to 5 halves. So rational number, the same value twice. And this is going to be really important when we do some graphing. This means that my graph is going to bounce at that point because it is a double root.